In this lesson, we're going to talk about making inferences from sample surveys. But first, let's define parts of statistics. So we've actually already talked about this in our previous lessons without formally defining it. But there are two major branches of statistics, one called descriptive statistics, which is basically organizing your data and summarizing it into a visual, some kind of display or summary. So like when we did the box and whisker plot or the histogram, that would be descriptive statistics. Then we have a second part to this, which is called inferential statistics. And you might have heard about making inferences and things in science, but basically it's using some kind of sample to come up with conclusions about a population, kind of like what we were doing in the previous lesson. So that's something we would do with data to make a reasonable prediction, or what's called an inference, about the entire population, because like we said before, it's really difficult to actually make concrete conclusions about an entire population by using the whole population data, because it's pretty much impossible to get everybody in a population to respond. Or if you're studying the population of some kind of creature, you're not going to be able to get out into the wild and find every single one of them. So we do our best with making an inference from a sample. Now, what's really, really important is you see here that this only works if our sample is actually representative of the population. So that means absent of bias. So for example, if we are polling everybody in high school, all the students in high school, you're not going to just take 50 kids who are 10th graders. That's not representative of the entire population, right? Or if you're trying to get information about everyone who's taking math, you're not going to just poll kids who are taking geometry and nothing else, right? Because you want it to actually be representative of the entire population. So that's key. But as long as we have a representative sample, then we can use our sample information to estimate the population. So for example, the numbers of friends for a random sample of 40 teens using some social networking website are shown below. We want to estimate the population mean. So remember, this population is for all teens. And like I said, can we get out there and talk to every single teen? No. So what we can do is, if we're confident that these 40 users we talk to are representative of all teens out there in our population, then we can use the sample mean to estimate the population mean. And just to remind you what's the notation, so sample mean is that X bar, population mean is mu, that's the difference in the notation. So all we're going to do is calculate the mean of our sample. So X bar is, we're going to take every single one of these 40 responses, add them all up, right? We're going to take that sum of that table, divide it by 40. So if I added everything up correctly, that would be 119,066 over 40, which is 299.15. So that's our sample mean. And then since we're going to use that to estimate the population mean, we're going to say the same thing, right? The mean number of friends for all teen users of the website is approximately 299.15. And again, that's because we did a random sample and we are confident that sample is representative of the population of those users. So that's why we can just use the sample mean to estimate the population mean. Okay, so you guys can pause here and do the U-try problem. When you're ready to move on, just go ahead and hit unpause. Like in the previous videos, I'll check all the U-try answers at the end. So when you're ready, we're going to go ahead and move on to the next example. Okay, so what we have to be careful of here is not every random sample results in the same estimate of a population parameter. What does that actually mean? Well, that means not every random sample will actually give us the same kind of estimate, right? And that's because we have some variability with sampling. Like you can sample 5 users or you can sample 500 users, and you can get very different data. So in general, the larger sample size gives us more accurate results, more accurate estimates. And if you think about it logically, that makes sense, right? If you have a population of 11 million and you just talk to 5 random people, you can be confident, yes, I randomly polled them, but are they representative of all 11 million? Probably not. But if you talk to 1,000 people, then you might be a little bit more confident, right? If you talk to 1 million people, then you're even more confident. So the larger your sample size, the more accurate your estimate will most likely be, again, as long as your sample is representative. Okay, so if we take a look at this next example, you can kind of see what I was talking about. The student paper wants to predict the winner of a city's mayoral election. There's two candidates, candidate A and candidate B, running for office. And then they were running surveys from randomly selected residents of this city. And you can see in the chart, we have different sample size numbers and the number of votes for candidate A, and then we calculated the percentage, right, of votes for candidate A from that sample. And we can use that to draw inferences, right? Draw some conclusions from that data. So if you look, the first question, based on the results of just the first two sample surveys, so for this problem, right, just the first two samples, it's here, a sample size of 5 and a sample size of 12, right? This data. Do we think candidate A will win? Well, if you look at it, 40% and 33.3%, in any election, usually you need more than half, right? We need it to be more than 50. So just based on those two first surveys, we might say, no, we don't have confidence that candidate A will win because those percentage values, right, are less than 50. Okay, so that was based off of the first two surveys. And then if you look carefully, the sample size of those were only 5 and 12. But let's say the population of your city is closer to 100,000. Is that incredibly accurate if we only poll 5 or 12 people? Probably not. So if we look at the results as a whole, which one would we want to look at to kind of give our best inference or our best prediction, right, of what's going to happen? And that would definitely be whatever the largest sample size is, right, at 200. So just right here, this is our largest, right, sample. So then what we're going to do is look over at this percent and you'll realize, hey, if we polled 200 people, that number jumped from 33.3% to 59%. And now, yes, this candidate is actually getting the majority. So perhaps it's a more accurate inference or prediction to say candidate A will actually win the election. All right. So go ahead and hit pause here if you'd like to try the next try problem. And then whenever you're ready, we're going to move on to the next example. And we'll check all those tries at the end of the video. So moving on. So when we're doing our survey and making our inferences, remember, we're not getting 100% of the data. We're not getting the whole population. So there will be what's called margin of error. And you've probably seen this before, especially when you watch the news, if you read the news and you see polls like the percent approval rating of the current president, or polls about in an election year who might win your primaries, and they usually have some percent, but then in print somewhere below they might say, you know, the error is plus or minus whatever. That's your margin of error. So as our sample size increases, our margin of error decreases, and that kind of makes sense. Like we said earlier, the larger the sample, the more confident we are in our inference. The smaller it is, the less confident we are because it's just not large enough. So we have a formula to calculate margin of error, which is right here. It's just the margin of error is plus or minus 1 over the square root of n, where n is the sample size. Okay? So when you get a margin of error, let's say your margin of error, if we look back up here, for example, 40% of the people in a poll favor a new tax law, and the margin of error is plus or minus 4%, that means we actually have a range between 36 to 44%. That would be the range of people who are likely to favor that. So we want to calculate the margin of error just to let people know, right, we're not 100% sure, you know, exactly 59% of the people will vote for this candidate or whatever. So to figure out the margin, to figure out that band, we just take your percent, right? And we add or subtract that margin of error, that plus or minus. So if you take a look at the next example, in a survey, 2,680 people in the US, in a survey of 2,680 people in the US, 34% said that movies are their main source of entertainment. So if you look back up here, this P would be that 34%. So we're going to add and subtract from that 34%. All right. So what is the margin of error for this survey? So our margin of error remember is that formula plus or minus 1 over the square root of n. And what is n here? N is your total number in your survey. So this will be plus or minus 1 over the square root of 2,680. Okay, and we're going to go ahead and round that to the nearest thousandth. So that will be plus or minus 0.019. So I just did that in my calculator. So that is the margin of error. Okay. So then converting that to a percentage, the margin of error is about 1.9%. I'm converting that to a percentage because typically we do like to give our answer as a percent, right? So it doesn't matter if you do leave it as 0.019, but because if you look at the next question, it's asking you to give the given interval that is likely to contain the exact percent of all people. Because I know in this next part, I'm going to give the answer as a percentage. I just converted it to a percent right away. And that way I can just add or subtract from 34%. But again, if you're going to convert 34% to 0.34, you can leave your margin of error as 0.019 and just convert your answer at the end. I just did it early because I looked ahead. So just a heads up there. But if it did specifically ask for the margin of error as a percentage, please do give the answer in the format requested. All right, so again, how do we find the interval? Nice and easy, we just add or subtract that margin of error. Right, so I'm just going to take that percentage 34, which is that P, and I'm going to subtract that 1.9% to get 32.1%. And then on the other side, we're going to look at 34% and add that 1.9% to get 35.9%. And again, if you wanted to do 0.34 minus 0.019, go for it. Just convert that decimal to percentage afterwards. Same if you want to do 0.34 plus 0.019 and then convert 0.315 to a percentage, or excuse me, 0.359 to a percentage afterwards, go for it. But again, we want the answer here in percent. So there's our range. So it's most likely that the exact percent is somewhere between 32.1% and 35.9%. So there we go. So it's likely that the exact percent of all people in the US who use movies as their main source of entertainment is between 32.1% and 35.9%. Cool. So you have one U-try problem here to practice that margin of error. So again, pause so you can work on your U-try and then hit unpause when you're ready to move on. Okay, and now before we actually do the answers to the U-tries, I'm going to scroll down here, and I have one extra bit I want to talk about. So estimating the population proportion. So what I did was I just took the table from that first U-try problem, and I want to talk about what we do to estimate the population proportion, because you actually have a problem like this in your practice. It wasn't in our notes, but it is in your practice, so I want to make sure you know how to do that. So remember, the population proportion is kind of a fancy way where we talk about the percentage. So for example, let's say we wanted to use that data table to find the proportion of users with more than 300 friends. So how do we do that? Well, remember, the population proportion is just basically a percentage. So we're looking at a number out of a total. Oh, I should mention, if you want to add this to your notes, feel free to add it into the margin on the front page, or if you want to whip out a second sheet of paper, you definitely can. But coming back to this, so the first thing I want to do is figure out, well, how many of these people surveyed actually have more than 300 friends? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Am I missing one? Oh, I missed that big one. That's 418, 13. So we have 13 out of these 30 people polled have more than 300 friends. So that population proportion of the sample, so remember, for the sample, we use that p hat notation. That is just, again, how many we have out of the total. So we said we had 13 that have over 300 out of a total of 30. About to write 60, but 13 out of 30. So we can create a percentage out of that. So that is roughly 0.433 or 43.3%. And remember, as long as our sample is representative of the population, we can use the sample to estimate the population. So our population proportion is when we take off that hat and we just call it P, not to be confused with the percentage that we were talking about before. I mean, it could be the same thing, but again, this population proportion we call P. We're also going to estimate that now at 43.3% because if it's a reliable sample, a representative sample, and we feel like it's enough for us to, create inferences from, we can say the population is roughly the same as the sample. So again, you'll need that for your practice. So that's the last piece that I wanted to give you here. So whenever you're ready, go ahead and continue listening so we can go over the 3 U-Try problems starting from the beginning, the first page, down to the end. All right, so let's scroll all the way back up to that first page. Here we go. So that first U-Try, estimating the population mean, don't let that fool you, right? If we are using the sample to estimate the population, we just calculate mean from the sample. So add up all 30 of those numbers, divide it by 30, and we should get approximately 294 as our sample, as our estimate of the population mean. Okay? The next one, again, interpreting the results here. So we can see as our sample size is increasing, the percent of votes for the incumbent, the person who is already in office running for re-election, right, is decreasing. So we want to trust that larger sample. So as our sample size increases, the percent of votes is decreasing. And that last one, that 42.5, is definitely not going to give him or her the votes that they need. So we're going to be pretty confident that, or we're going to make an inference with some confidence that the incumbent's not going to win, right? The last U-Try problem here, just figuring out the interval that's likely to contain the exact percent of all people who use the internet if we have 1,028 people surveyed. We can do the margin of error, which is plus or minus 1 over the square root of 1,028. Converting that to a percent because I want to give me my answer as a percent, I get about 3.1%. And then adding and subtracting from 87, we get the interval 83.9 to 90.1. Okay, so that wraps up this lesson. Remember, if you do have any questions, make sure you contact me with them. Otherwise, thanks for listening.